Okay, so let's solve our sample problem number 3. So if you notice na, manotice na to sa sample problem number 3 that there is a variable force included in this sample. So our previous samples, we already discussed the total work done. Ang first is just the work done, total work done, and then on the second sample, we already included the energy, the work and energy principle we applied in the second problem. Here we can also apply the work and energy principle in this problem, but we have a one variable force here. So let's try to solve the problem. So this is for a short time, the crane lifts the 2.5. So this is capital M and then small letter G. So a capital letter M, that is not milligram, that is megagram, with a force of F is equal to quantity 28 plus 3s squared kilonewtons. So this is in SI units. So ang SI units, energy and work is equal to joules. And what else? Determine the speed of the beam when it has risen S is equal to 3 meters, and also how much time does it take to attain this height starting from rest. So ato ang i-write niya po ng given sa aning problem. So we have a given na to is ang mass is 2.5 megagrams. So megagrams, that is times 10 to the 6 grams, or 2.5 or 12.50 times 10 cube kilograms. Sa pay given na to, we have the force equals to 28 plus 3s squared kilonewtons. So I prefer to write this in newtons para mas dali itong solving later. That is 28 plus 3s squared times 10 to the 3 newtons. So if you notice that the force here is in function of the distance s. So we have s at 3 meters, that is our final position. Let's name that s sub 2. And then what is sa pailan given nato? I think more than given, and then we were asked the speed or the velocity at s is equal to 3. So na pa isa ka given starting from rest. So ato at s equal to 0 meters, ay ato ang velocity is just equal to 0 meters per seconds. So again, kung mag-drawing mo FBD ani no, let's say this is the FBD. Motion is upwards, so the acceleration is upwards. We have a force F here, which is equal ani? Equal to 28 plus 3s squared times 10 cube. And then ang ato ang weight is equal to 2.5 times 10 cube kilograms times 9.81. So that is equal to, pila equal ni weight, 2.5 times 9.81. So that is equal to 24.525 times 10 cube. So that is times 10 kilograms. And then we have a force or acceleration upward. So unsay buhaton na to ani? So okay, so we have the Newton's second law applied here. So ang next na to buhaton is imong makasamang force ani diretso. So itong buhaton is we write the work energy principle. We have the initial kinetic energy plus the sum of the total work done is just equal to the final kinetic energy. So unsa man natong initial kinetic energy, di ba? Initial kinetic energy is equal to 1/2 m, then initial velocity is equal to then squared. So itong initial naman given initial velocity is equal to 0. So therefore our initial kinetic energy is just equal to 0. And then what else? What else do we have here? We have, let's solve for the work. So summation of the total work done. So ato na siyang i-solve. So we have a work due to the force, and then work due to the weight of the object. So the work due to the force is just equal to, since this is a variable force, sa to pa, di na to siya masubstitutan diretso. We integrate the equations. We have here the force times the displacement from S1 to S2. So substituting, we have the 28 plus 3s squared 10 cubed ds from S1 to S. So we will have the work due to the force, which is equal to 28s plus, we have the s cube times 10 cube from the initial s, which is equal to 0 to s, and then finally we'll have 28s plus s cube times 10 cube. So ato sa siyang i-write in as a function. This is the work due to the force nga kaning F. Next is the work due to the weight. So constant naman siya, then we can write just the weight, 24.525 times 10 cube, and then times the distance s. How about our final kinetic energy? That is just equal to 1/2 the mass times the final kinetic energy, v sub 2 squared, then equal to 1/2 times the weight, that is equal to 2.5 times 10 cubed kilograms, and then the square of the final velocity, or the velocity at 3 meters. So this is our equation. So substituting it from this equation, that is just equal to 0 plus the total work done. So ang total work done, so ang work due to the force, since pasaka ang motion, pasaka ang force, this is a positive work. Ang weight is panaog, and then ang direction sa weight is panaog, ang motion is pasaka. So this is a negative na work. So we can write from our sample here, we have 28s plus s cube times 10 cube minus work due to the weight, that is equals to minus 24.525 times 10 cube s is equal to, you have here the velocity, so that is 1.25 times 10 cube square of the final velocity. So if you notice na i-common nila nga 10 cube, so ato na ni silang makancel. Pwede na kaya dako ang values. So final nga right ato na siya isulat. We have the 28s plus s cube minus 24.525s is equal to 1.25 times the square of the final velocity. Ato nang i-simplify further. We will have s cube plus, we have 28s, and then minus 24.525s. So ma-minus na to sila because they have the same literal coefficient. So we have 28 minus 24.525, that is equal to 3.475 is equal to 1.25 v squared. So divided by 1.25 sa whole equation. So we can have v squared is equal to 1 divided 1.25. So we have 0.s cubed plus on this side we have 3.475 divided by 125, but 2.78s, we forgot the s here, and then we square both sides. So we have the velocity is equal to 0.8 s cubed plus 2.78 s to raised to 1/2. Okay, so again, if we review, we were asked about the speed. We also asked about the time. So we forgot about the time. So the time at s equals to 3 meters. So we have this formula. At s is equal to 3 meters, then we can have the velocity is equal to, velocity, that is just equal to square root of 0.8 times s cubed, so 3 cubed, plus 2.78 times 3, So our velocity at s equals to 3 meters, that is equal to 5.472 meters per seconds. Now, unsaon man nato pag-solve kay time? So ato lang to i-rewrite again. We have the velocity is equal to 0.8 s cubed plus 2.78 s raised to 1 half. And we know that the velocity is equal to ds over dt. So we have here ds over dt is equal to 0.8 s cubed plus 2.78 s raised to 1 half. And then if you can see na s diri and we have ds here, so we can have a variable separable for this equation. We have this is a differential equation, so we have ds over 0.8 s cubed plus 2.78 s raised to 1 half is equal to dt. Integrating both sides, we have time is equal to the integral of this. So actually this is a complex integration, but if you solve this using a integral calculator, we can solve from 0. We have a lower limit of 0 to 3 meters. So we can solve for the time that is just equal to 1.79 seconds. So our answer for the sample problem number 3 is the velocity. We have a 5.47 meters per seconds and a time equal to 1.79 seconds. So unsa tong gibuhat, always draw the FBD and then reorient it sa para mas dali, but since this is already oriented, no, straight na, wala na angle, then pwede na ni diretso, then we write the work energy principle, the initial kinetic energy plus the total work done plus the final kinetic energy. And then our work here, so this is invariable man. Sa ato pa, to get the work of due to this variable force, ato siyang i-integrate. So that's why we have here an integration. Pero ato sa siyang sulat in function form because ang giasa ato is the velocity and the time. And then we have the final velocity, final kinetic energy here. So we have shown here. And then substituting all the values here, we have a velocity as a function of s. And then at s is equal to 3, substituting the value of ds is equal to 3 meters here, we got the velocity. And then we were asked also for the time, and then ang may relationship si velocity of time, which is equal to ds over dt. And then timing po nga ang velocity is a function of s. So ato siyang variable separable. And then we arrive at this solution or answer that the time is equal to 1.79 seconds.